Hi everyone, my name is Joshua from Tag. Let me welcome us once again back to my channel, and I want to believe by now we've seen the previous videos I shared on the fundamentals we need to understand before using R. So today I'm going to take us a step further into what basic statistics looks like in R. And this material was prepared in one of the trainings I went for at the Federal University of Agriculture, Abeokuta in Ogun State. And this same material was also used when I went for the training at the Federal University of Technology, Akure. All this happened shortly after my master's program at the University of Ibadan, Nigeria. So let's go straight into the outline we would be using for this particular lecture series. So first, we're going to talk about statistics briefly, and then we move into what variable is all about, univariate and multivariate data, parameter versus statistics, and then we move into summary statistics, where we're going to talk about centrality, the mean, the median, and the mode, counts, percentages and proportion, quartile, percentile, and the 5-number summary, spread, talking about the variance, the standard deviation, and the IQR. And I'm going to add some other options to this ones that we have. So what is statistics? This is the practice of turning data into information to identify trends and understand features of population. And one of the most important keywords from this definition is data and information. So this can be best seen with the concept of input and output, like something raw and then inserted into a system to get an output that is already refined. So the first thing every statistical analyst will always face in the course of performing data analysis is dealing with the raw data. In other words, the records or observations that make up a sample. Now this data could be stored in a specialized R object, and then talking about variable, which we have done and treated extensively well in one of the previous videos on how you can create variables in R. So what is a variable? A variable is a characteristic of an individual in a population, the value of which can differ between entities within that population. So let's see the types of variables that we have. The first, there are two. Numeric variable is the first one. This is one whose observations are naturally recorded as numbers. They are of two types. The continuous variable, they can be recorded as any value in some interval up to any number of decimal, for instance 15.12 millimeter. The other form of it is the discrete. This takes only distinct numeric values, and if the range is restricted, then the number of possible values is finite. For example, it doesn't make sense to observe 15.245 heads if you are to observe the number of heads in a 20 flip of a coin. Doesn't make sense. So it is either we have one head and one tail. So the other type of variable is the categorical variable. Like some discrete variables, categorical variable takes only one of a finite number of possibilities. Unlike discrete variables, however, categorical observations are not always recorded as numeric. So there are two types of these variables. They are the nominal categorical variable, those that cannot be logically ranked, e.g. sex. Sex has two categories. The other of these categories is irrelevant. So when you are performing some kind of analysis, you can't say male is greater than female or female greater than male. So the next form of it is the ordinal categorical variable. They are variables that can be logically ranked, e.g. drug dosage with possible values of low, medium, and high. These values can be ordered in either increasing or decreasing amounts depending on the nature of the research. So this is very important for us to have an understanding of the nature of the variable, so that when you are performing your analysis in R, you would be able to change the classes of the variables you have in your data set to the right classes they are meant to be before proceeding to analyze. So I provided some very simple examples that can lead us into what variables is all about in R, mere running the codes we have here. The check WTX is an example of the free data set we have by default in R. And so when you run this line of code that we have in this place, it's going to bring out the first 5 rows for all the columns. When you run the next line of code, it's going to give you information about check WTS dataset that we have available in R. When you do what we have on this line, check WTS $weight, these are things you should have understood by now following the previous videos I made on how to access a variable in a data frame. So when you put the $, you are interested in seeing information about the weight variable alone. The same thing is applicable to what we have for the feed. So let's talk about univariate and multivariate data. So when discussing or analyzing data related to one dimension, you are dealing with univariate data. For example, the weight variable in the earlier example, check WTS $weight, is univariate since each measurement can be expressed with only one component, a single number. When it is necessary to consider data with respect to variables that exist in more than one dimension, in other words, with more than one component or measurement associated with each observation, your data are considered to be multivariate. Now, take note of what I said beneath. Multivariate measurements are arguably most relevant when individual components aren't as useful as when considered on their own in any given statistical analysis. For instance, the spatial coordinates. So an example, what we have with this particular data set, also freely available in our code quakes. And when you run the line of code we have here, you would get again the first 5 observations for all the columns. When you run this line of code, you are going to get a plot that looks more like a scattered plot, having on the x-axis the longitude and the y-axis the latitude, and the labeling for the x-axis is the longitude and the labeling for the y-axis, which we introduce using the ylab argument, is the latitude. So let's talk again about parameter versus statistics. Now, statistics as a discipline is concerned with understanding features of an overall population, defined as the entire collection of individuals or entities of interest. Now, the characteristics of that population are referred to as parameters. Estimates from a sample are known as statistics. So when you think of parameters, think of population. When you think of statistics, think of a sample. So I will stop at this point and take us to R to quickly provide an explanation to what we have in the short theoretical explanation I make, and take us fully into summary statistics now, where we would learn more about the mean, the median, and the mode. Thank you very much for your attention. See you in the next video for the practical example in R. Gracias.